Good morning, good afternoon, and good evening, depending on where in the world you are today. Thank you for joining this Tech Strong Learning Experience webinar with Gremlin. My name is Amanda, and I'd like to welcome you to today's program. This session is being recorded and will be available on demand shortly after we conclude today's session. We will also send you a link to your inbox after the live session concludes. Please send your questions in the Q&A chat for our speakers today. You can find that on the right-hand side of your screen, and join us in the chat by telling us where you're from. Feel free to tell us what the weather looks like today. It's sunny here in Illinois. And share your experiences about today's topic, your comments, anything that you'd like to share about today's topic. We want to hear and engage with you, especially our speakers as well. We also have some resources available on the left side of your screen for some additional handouts about today's topic. And so we're going to kick this off by talking about how to build resilience through your SDLC, lessons from a top 10 bank. And today I'm joined by three great speakers all from Gremlin. We've got Anantha Newman, Senior Reliability Specialist, Anantha Movva, former head of SRE and Performance Engineering, and Jason Heller, Technical Services Manager, all of Gremlin. And so we want to thank our speakers for joining us today, and thank you all for joining us today. Andre, would you like to take it from here?
Yeah, gladly. Thank you for that intro, Amanda. Hey, everyone. Thanks for joining us today. Amanda already did a great job of introducing us, but again, my name is Anantha Newman, Senior Reliability Specialist here at Gremlin. I'm joined by Anantha Movva, who's going to be walking us through his experience building resilience throughout his SDLC at his previous company. And then I'm also joined by Jason Heller, a Technical Services Manager, who's going to walk us through a demo about how this all works in practice using Jenkins. So a quick look at our agenda for today. We'll start by looking at the problem that led up to this project. What challenges were Anantha's team is facing? What results were they hoping to get from this? And what led them down this journey? I'll hand it over to Anantha, who will actually walk us through his journey from day one up to production. We'll hear about the outcomes, the stumbling blocks that they ran into, and also talk a bit about how you can adapt this to your own organization's systems and processes. Then, like I mentioned, Jason will show us a demo of how this works in practice using Gremlin and Jenkins. He'll show us a bit about how to use Gremlin itself, how to integrate it into Jenkins, how to use our API to initiate experiments and tests from Jenkins, and also just give you some ideas about how you can use Gremlin's features to make your own CI/CD pipeline and SDLC more effective and more reliable. And again, like Amanda mentioned, we'll save some time at the end for Q&A. We have about 15 minutes blocked, but we might have a bit more time depending on how the presentation goes. So please don't hesitate to put your questions into that Q&A panel. You can ask us about Gremlin, about the demo, about Anantha's experience, and we'll be sure to answer them at the end. So now I'll hand it over to Anantha, who will walk us through more of his journey. So take it away, Anantha.
Thank you, Andre, and welcome all. And so let's start off with, I believe we all are here because we do have some relevance and agreement in terms of why is resiliency important, and especially in SDLC. So a lot of the time when we are doing delivery from an SDLC standpoint, every individual contributor, especially from the developer community, they're focused into their specific delivery item. And by the end of it, when we move into integration, we might see surprises, we might not see surprises, we get lucky. And inculcating the practice of anticipating the outcome throughout, irrespective of your one functional area or one piece of code that you're delivering, is very important in order to understand the impact. So move on to the next slide. The first steps, again, towards resiliency is a lot of the time we don't understand how the integration component that we are talking to from a solution standpoint behaves. We expect it to behave within a certain set of boundaries, either with a contract or a set of rules and a set of parameters that we establish as part of our integration standards. Now, that's not a developer's primary responsibility to ensure that their piece of code or delivery aspect actually adheres to unexpected conditions when we actually integrate. A lot of these move into operational area, but with hyper-connected world, what we started seeing was with cloud being adopted more rapidly, a lot of these dependencies are becoming inherent, weakest links from a resiliency and reliability standpoint. That means the developer already has, and we're asking the developer to say, can you ensure that it is reliable? Can you ensure that these are the reliability requirements or resiliency requirements? How do you take care of it or provide them with an enablement? One of the things that we observe is the developer already has 100 things on the plate to continue and do. And we are adding one more thing, and the bandwidth for developer is probably 40 or 50. And then he comes back and says, this is not part of my requirements. And you're adding an additional thing on top of the bandwidth that I already have limited. And I will prioritize that on things that I feel that are important for the delivery. And so goes the resiliency. So the approach that we took was, how can we actually enable the developer with the capability, with resiliency as a service, and bake it into their SDLC activities that they normally do with minimum amount of time being spent. Having said that, that enablement, pushed us to a rapid expansion from an enterprise adoption standpoint. That idea that developers are not responsible to actually create these assets to use it as a self-serve, but actually tap into the existing assets to use it as a service. And getting there is not an easy task. We had to go through several iterations, but here we are presenting and sharing the experience of what exactly worked in that aspect. So, so that this is the first steps towards resilience from an enterprise scale, how to adopt and how quickly we can go and what needs to be set up. Next slide. So if you see this slide, you'll see a lot of activities that resonate very well with each of the developers or anybody involved in the SDLC in their life cycle. Support tickets, functional testing, performance testing, integration point, maintenance of the pipeline, upgrades, currency, and bug fixes, and so on and so forth. What we saw was when the developer is inundated with a lot of this BAU activities from an SDLC, from a product or an application, they don't have the appetite or the response or actually the interest to take over resiliency separately as a practice to inculcate. And they're not being responsible because a lot of them seems to be an operational aspect in a general thought in any enterprise, and say, hey, that's operational aspect, and we can take care of it in an operational way. So they traditionally tend to prepare it at the end of the life cycle, but shifting the responsibility and the ability to fix things up the stream towards the left is the key to enable that the operational aspect is actually seamless. So prevent it even before it happens. And having said that, that's how we thought upon enabling the developer community to be able to tap into this as a service. Next slide, Andre. So again, the goal is enable the developer to quickly use and reduce the amount of time that they actually spend to be able to get to this data points and consume, bring the concept of chaos engineering into the SDLC. And Gremlin provides a fantastic, ability to create those assets to be tapped into by the developer community. And we don't want to amend a lot of data and activities and things to do from ground up. So we present the data for the developers to tap into and review and qualify them. Is this data point valuable for me? Is there a gap in reliability or resiliency identified? Can we go and improve that? And the bottom line, takeaway is minimum involvement from the developer from reviewing the right data points. The data points that we bring by inculcating this as a practice is very valuable. That's the biggest value and takeaway. And then the maximum takeaway is if I have an opportunity to improve within the data points that are presented, then that's adding value. If not, we know we did not uncover unwanted. We did not uncover nasty surprises or the resiliency gaps. So effectively, providing them with the ability to tap into this as a service and then use the data points seamlessly as a feedback loop and shifting that ability to fix things and deliver the right thing into the left is the key. And all of this happening with the minimum involvement of a developer. And that's the primary goal. Next slide. So the phase that we tapped into is actually the performance testing phase in SDLC. Having said that, it is just not limited to performance testing phase, but that's the biggest bang for the buck that we identified. And the approach taken is, let's identify, the interaction points and set of attacks that the interaction points can potentially go through as a scenario, and then run these scenarios, collect the data, analyze and qualify them for improvement or not. I mean, they are behaving as expected, fantastic, go through. They're not behaving as expected, let's analyze the data point to see, is there a reliability gap? Should we fix it? And let's take these data points and spend like 15, 20 minutes after the simulation with the development team to say, does this look like it is expected behavior or not? And then move on. So this cycle of data point presentation and interaction with the developers has become a part of the regular activity for both the platform performance team and also the development team, so that it becomes kind of like a daily stand-up call for resiliency. That's one of the key things that this helped us put forward from a resiliency standpoint. And developers didn't mind that, because the data points that are presented and discussed there are very valuable for the own product that they're actually building and deploying and providing it for the next stage of the project. So it turned out to be a very good practice and an approach, and that worked very well. And it was easily expandable in terms of an adoption standpoint from an enterprise scale. So the fully automatable call with the scenarios integrated into the pipeline with minimum involvement from the developer, and their ability to actually review the data as a takeaway to identify gaps and contribute to fix those gaps, was one of the biggest takeaway from this practice itself, and how they're set up and how the resiliency as a service concept came up. Next slide. So here I hand off to Jason. He's going to show in practically how it is done and we can take questions after that. It's a fantastic demo. Enjoy. Jason.
All right, thanks, Ananth. Okay, we can just flip to the next slide here. Of course, when you hand it over to the tech guy, the first thing I do is throw up more slides. So we'll jump through these quickly and then get to the actual build out. So I really wanted to talk and take Ananth's lead on this, on building this out in a couple of ways, right? But taking a journey to eventually get to, hey, what's the most automated, easy mode for the developer side of it? But typically people start in on this chaos engineering and reliability testing, right, at just a single point inside the infrastructure. So you're looking at your application or the thing of the component that you built, right? But the reality is we also want to be able to test other components, like the dependency piece of this. But the first step of this is just, hey, we want to enable developers to be able to go in here and add some CPU load or latency in this example here to do some validations for, say, their Kubernetes configurations, or maybe they want to just validate a new feature that they implemented, say, hey, I just want to see what happens with this new feature when I add latency onto the infrastructure. So in our example, right, we'll be looking at kind of the latency side of this for this checkout service. The next model, if you can advance the slide one, the next model is looking at this in a more holistic view. And what we're doing here is I have this open telemetry demo. It's running in Kubernetes. So we'll see it, implemented in the Gremlin side of it, how we pull all this together and then how we test this. If you build out the rest of these slides, we'll just kick through. So the idea is to take that architecture, right, this microservices with all these containers that are interacting with it, and give the developer the ability to automatically detect the Kubernetes configurations in the environment, and then automatically pull down the dependencies that are on that application. So it's one thing to go and test and say, hey, what's the reliability of the the individual app? But as Anantha was saying, right, it's really more, hey, what happens for all the dependencies as well? And how do I give the developer the ability to go discover those dependencies? Maybe they just inherited this application, and so we're starting from scratch, right? You can kind of pull down this dependency list from Gremlin with an API call, right? Or we can set up test suites to basically run a standard set of tests across this entire environment. And then the last piece of it, and Anantha kind of touched on this as well, is how do we build a standard set of tests that we can hand off to the to the users, and really you're doing chaos engineering, reliability management as a service. And the idea is that we're going to wrapper this eventually, right, with, hey, here are the parameters you can pass in. We have a standard set of tests. If you click this button or you hit this API, it goes and it executes this series of tests, comes back with a score to give you a pass-fail in your CI/CD pipeline. Okay, so let's actually jump into the actual product here. Okay, so what we're going to do is we're going to start out by creating a scenario in here. We'll use that checkout service as our example here throughout the demo. And what we'll do is we'll build the different use cases that we just talked about. So the individual scenario, a battery of tests that we want to do on there, and then ultimately, how do we get this to a chaos engineering as a service implementation? So for a new scenario, let's start out with the checkout service again. So let's just call this add latency to your individual checkout service. And we'll give a little hypothesis here saying, all right, what we're going to do is we're going to leverage Datadog in this example, but you could leverage really any other API to get pass-fail criteria for when we're running this test, what makes it successful. Ultimately, it's that I didn't generate some alarm or alert, or I didn't violate the SLA that I've set in place here. So what we're going to do is add a health check inside of this. And we'll pick let's do the front-end web store as an example on here. And the idea is that what we're doing is we're going to be testing the checkout service, but the success criteria is based on the front end remaining intact while we're doing this. And so the idea is here to kind of do a little combo test on this. So let's go create the actual test. In our case, we're on the Kubernetes side of this. So let's flip over to Kubernetes. Choose the namespace that we want here. I was lazy and chose the default. So glad this is recorded. When we go to the exact side of it, let's pick the checkout service as our deployment that we're targeting. Gives us the blast radius that we're looking to attack here. Then we come down and pick the actual experiment that we want. So we have resource type experiments where we want to exhaust the resources on a piece of infrastructure. So chew up all the CPU, chew up all the memory and see if out of memory manager steps in and stomps on it. What we're looking for, though, is on the networking side of this to go into the latency test. And we're going to give it some parameters. So in our case, 60 seconds of time and 100 milliseconds that we're going to run. So this is going to how we're building that test that we're going to go then throw into our pipeline. So if we update our scenario and we save this out, what this does is yes, go ahead.
Just a quick moment right here on the scenario when you're explaining it. So I wanted to chime in on how in a scaling scenario of having chaos engineering scale across enterprise, how we did it. We basically made it part of the performance test planning. A talks to B, B talks to C, C talks to D, E, F, and whatnot. So this integration point is identified in your E2E. So each integration point has a set of potential attack scenarios that are discussed and put up in a matrix. So we put all the A, B, C, D, and all the interaction points in the column. And then we came up with a set of attack scenarios in rows, and then we said, okay, this interaction point is going to go through this attack and see how it responds to that attack. And each of them had a pass-fail criteria, as Jason explained. And all of the scenario gets stored as one scenario on the Gremlin plane. Now, the moment you choose to call that scenario ID with a unique ID into any of your CI/CD pipeline as a trigger activity post-deployment or post-functional validation, that basically executes it. We chose to do it as part of our performance test execution. So when the test is running, these are the 60 different attacks that we want to go through in the multiple interaction points and shows the results. And then we had an integration with our APM tool. And the next step was to integrate those pass and fail with the ticketing system. But I wanted to just emphasize on the fact that that integration as part of your planning was a one-time activity that was done, and then you keep on, doing that along your as part of your CI/CD activity with performance, and your score gets updated in your reliability scorecard. So go ahead, Jason. I wanted to emphasize that on the ease of actually setting that up once and then reusing it across the board.
Yeah, no, that's a really great point. We come out of the box with some, default scenarios that are on there, but ultimately you're building like templated out scenarios, and that's we'll walk through how to actually customize those from the user side of it. So once we've built this on here, we can use this the Gremlin API piece of it at the bottom here to go get the commands we want to run. So in our example here, right, we want to go just do a curl command maybe from Postman or something, but we can also drill in here and get the full parameters. So when you're building this out, you can look and say, all right, here are all the options that I'm sending into this, right? The specific name of the device or the pod that I'm attacking in this example, right? What test we're running on there, all the parameters, all of that is kind of dumped out to here. So what we could do is go onto the API side of this, and let's go try and build one out. All right, so we'll grab the ID of the scenario that we just created, and we'll just grab it out of the URL here. Make my life easy. All right, and then the specific team that I had, it's J.A. Heller team, and then the payload that we want to put in there. So we'll start with just, all right, let's just throw something onto that scenario. So we're not overriding any of the defaults. All it does is go off and run that test as configured. And so if we go back on the Gremlin side of it, we should have a test that's now running in here. So add latency on the checkout service is now running with those default parameters. Now, when we go to the Jenkins side of this, we want to take this and put this into a new pipeline. So let's say checkout latency. There's one already. Let's do that one. And we'll create our new pipeline. In our script side of it here, let's go throw in checkout pipeline. And again, this is all, we typically just template all of this and then get back to, just filling in that test ID. So at the top of this, right, I'm coming in and I have some credentials that are pre-canned inside of this. We have a couple steps that, depending on where you want to integrate it, to Anant's point, right? If you're in the build process or you're doing performance engineering testing, right? And then finally, you can kind of get down to the actual script you want to run. And that can literally just be this command right here. So when we build this out, we can just paste this directly into here, save this out, and we now have a pipeline to go run this implementation, right? So depending on where you want to integrate this, you just take that single block, right? Take the curl command that you created in there, and you're off and running on the Jenkins side of it. So what this will look like in here, get an overview. Ours is pretty straightforward. We're just doing kind of some initialization stuff, run the chaos experiment, and then cut out. So if we take the kind of the next step on this and say, all right, now I want to actually say, all right, here's the tests for a compliance standard that we're setting inside of the corporation. And we go to this test suite side of it and say, all right, I want to register services in here. And for those services, let's go back. We'll use the checkout service since that's the one we're picking on. I want to build a series of tests. And I say, look, application developers, we are setting a standard here that all tests, all applications must be able to handle 50%, 75%, and 90% CPU load on the underlying infrastructure that you're deploying your application. So from the design of the application piece of it, right, we need to have load balancers in there or Kubernetes auto scaling, things that can handle when we ramp up the CPU on the infrastructure underneath it, right? So we have kind of the resource exhaustion side of it, testing some of the redundancy pieces of it, and then ultimately get down to the dependency side. And so we discover all these dependencies, but then we also create a series of tests for the dependencies. So now we have that same kind of health check idea where we're going out to the Datadog or Dynatrace or whatever we're looking at. And we're saying, hey, what's the user experience right now on the checkout service? But what happens to the checkout service user experience when I fail the currency service, or I add latency onto the email service, or the SSL certificate is going to expire on the product catalog service? So we're looking to test not just the individual app, but the dependencies of that application. But ultimately, that's all great and all. But what we're really after is creating a run all button here and an API, a single API endpoint to run this entire battery of tests. So the developer can kind of jump in and say, hey, by registering my service, let's say it's in Kubernetes, I put a single annotation in there that automatically creates this run all and the API endpoint for me. So now if we go into the Jenkins side of it, let's create a Jenkins pipeline that's a little bit more complex on this one. And we'll do, I say, test suite. If I could spell. Hey, there we go. All right, we'll create a new pipeline on here. This time we're going to go run the test suite, and we're going to use that to do kind of a pass-fail condition for the build process. So if I go back to my Visual Studio side, I know everybody's cringing. I should have been using VI, but you have to deal with me. All right, idea on here is we've still got the same kind of credentials that we're using before. We're going to go, insert this into, say, the build process. We're then going to go and evaluate the reliability score. So we're going to go hit that API endpoint for this specific service that we created on here. And now you can start, seeing how we can take this service ID and just give them, hey, here's the entire template on here. If you just simply change your service ID on here, it will go and generic call into the system and go run the standard battery of tests against this. Then we're setting, okay, what's the minimum score on here? And you could argue whether it should be 100. You should be always compliant, but we'll just say it's 80 in this example. When we roll all the way down to the bottom, though, this is really what we're after. I want to be able to have a single API call, return back the scoring component that happened from that, and then make basically a go, no go on the build process right here. So it's basically evaluating that reliability score that came back from running that battery of tests. Okay, then the next side of this is taking it one step further on here. So if you build this out, guess I'm not compliant. So there you go. So when we look at the actual, actually it is funny. I bet the checkout service is not above 80. So when we run this test suite, right, we get the no-go on here, right, and we basically fail to do the promote to production, right. So if we want to then say, all right, well, how do I make it even easier to do for the chaos as a service? Let's go back to the checkout latency side here. And let's add parameters into this. So now what I can do is say, all right, instead of talking Gremlin directly in your own pipeline, right, why don't you just call the pre-approved pipeline with some set of parameters? So go back to Visual Studio here again, grab up our parameter block. And we'll drop this in here. Save this out, and then we'll build and reevaluate. All right,
Jason, while this happening, I wanted to emphasize on it. While the steps that Jason is showing here, intricately shows the simple setup that was done. This is a one-time setup in order to make that as a service. In the sense, once your pipeline is set up, you're going to take this ID and then put that ID from the scenario ID from Gremlin, and then interject it into any phase that you want, whether it is a component level validation or a unit level validation after the developer's own developer workbench build. It can still be done. That means you're going to do this as early as possible in pure play shift left. That gives you a lot more visibility into your reliability gaps, way ahead in the game, versus getting all the way. We chose to do it in performance phase just because it's a very good point where the real world conditions are actually simulated. And the data points that come out of this real world conditions are very valuable in terms of resilience and reliability. And we chose to do that as a non-negotiable phase as part of the process. So go ahead, Jason.
No, that's great. All right, and so just real quick to kind of close in on this is, now that we've added these the parameters on here, we're going to allow the user to say, all right, I'm going to let you change the length of the test. I'm going to let you change the CPU cores that you run on, and I'll let you change the CPU capacity. But for the latency side of it, I'm going to create a fixed list, say, of, hey, I'm going to put 100, I'll allow you to configure the latency rather, but then I won't let you run it against different services, or I won't let you change other parameters of the latency test. So when we talk about as the service piece of it, especially when we're talking Kubernetes and shared infrastructure, When we start doing like host failure tests, we start doing black hole type testing, we want to make sure that we've contained the blast radius from even the user side of it that are implementing this as a service. So we want to prevent, cross namespace, testing. We want to prevent rebooting, infrastructure that isn't yours, right? So through these parameters piece of it, you can get granular control for who can run what, and then you basically give them a pipeline that they can go execute and pass these simple parameters, and it executes all of that testing from that run all button that we were looking at earlier. And so ultimately at the end of this whole thing, what we're looking to have generated, right, is this reliability score component for this, getting the pass-fail conditions for all of these, and then ultimately rolling that all up into, say, the team scoring reports. So we can look across the application stack that's here, maybe even across teams at a company level, and get an idea of, hey, where are we on the testing piece of it here? Maybe we have some tests that expired, so we can set expiration thresholds on here saying, hey, you should have run this. Or we have tests that have failed and we need to go investigate on there. But again, since we're constantly saying API, all of this is available via the API side of this. So as part of the build process and evaluations, right, we can start adding that in there. And additionally, I'd say, as part of the, post-mortem, when we do run into problems, building out those scenarios is a really good way to add use cases to your test suite. So that test suite that gets automatically created is nothing more than user-created scenarios that you think are appropriate for your team, and those will get run and added to this report. Okay. That's all I had from the demo side of it.
All right, excellent. Thank you, Jason. I will share my screen again. And while I'm doing that, also just want to mention that, Jason and Anant both mentioned a lot that this is a one-time thing. You set it up once and it's ready to go. Same thing for Gremlin itself. Gremlin uses an agent-based model to basically orchestrate the experiments and scoring on your system. So as long as your platform team deploys that, it would able to automatically detect your services, detect the hosts that are running in your environment so that you can actually get these tests up and running just by passing in the parameters. So just a quick reminder, we do have Q&A coming up in just a couple of minutes. Feel free to enter your questions into chat or the Q&A panel, and we'll be sure to get to them. But just really quick to wrap us up before that, just to go over some of the results that Anant's team saw, because they really got a lot out of this. He can definitely expand more on this, but I just want to give you guys the quick summary. So what it really came down to is what opportunities do they have to improve reliability and resilience. So some of the things that you can get out of this just by being able to run these experiments in pre-production or on your way to production is finding those incidents that could have become P1 incidents, or rather those risks. There are risks that are inherent in software and systems, especially since they're changing so fast nowadays. Being able to catch those risks in the CI/CD pipeline before they're sent out to customers is super important. And you never know what high priority or high severity risks might be lurking in there. So this helps definitely track those down. In Anant's case, his team had a ticket tracking platform that they used to manage like development work and things like that. They were able to integrate Gremlin into that ticket tracking platform, rather, to automatically track these potential risks and create tickets. And what that led to was, again, this 10 to 20 minute turnaround time or mean time to acknowledgement from when that risk is first detected to when that ticket gets created and then assigned to a developer to work on that. And just one other thing to mention, we talked a lot about Jenkins in this webinar. This is all interchangeable. It can vary depending on your platform, but the Gremlin API is platform agnostic. You can use it with Jenkins or any other CI/CD tool. So don't feel like that this is just limited to Jenkins in this case. And so with that, let's see if we have any Q&A questions. Again, please don't hesitate to drop your questions in the Q&A panel if you have any. Oh, no questions, really? We covered it that well.
I was going to say, this has been a quiet crowd. Let's see. I might have a question or two.
Yeah, go for it.
Yeah. I'm going back through the slides. So one question I wanted to ask, besides the top 10 bank, like what's another use case where the product at Gremlin has actually like helped reduce a lot of that liability with some of these risks?
So a big focus of ours is financial services companies,
Right.
especially those larger banks, because their risk is so much higher than other industries.
Yes.
I mean, you can obviously consider industries like healthcare and even like e-commerce. Amazon has millions of dollars that are on the line for every second of downtime they have. So they have been going very strong into practices like this just to make sure that they can reduce as much downtime as possible to as little as possible. So I'd say primarily we work with financial services, of course. We work a lot with other SaaS companies to make sure that they can keep their services up and running, and a lot of retail as well. Just really industries that have a very, very high need for reliability.
Yeah.
Andre, if I may, I
Yeah.
would say any business or an enterprise, that do not want to see on top of the Twitter feed for negative reasons, irrespective of the industry, the domain, is a use case for being reliable and resilient. So, domain, the level of defense is heightened when you say financial. The reason is you have more stringent, regulatory needs in there, and the ability to see and access money and transact and move it from A to B or pay and whatnot. These things resonate very quickly. The same thing is I put in an order on Amazon or I'm watching a movie on Netflix. I don't want to see disruption. And the moment it goes off, I'm really pissed. If you see how the concept of chaos engineering came into life, it's actually through Netflix. So they designed and they came up with this idea. So, unfortunately, a lot of the team is where Gremlin is from, the founding fathers of Gremlin. So anyway, so the domain, I'm trying to say the domain is a parameter here. It's relevant. If you care about your business in being resilient and reliable, the use case is there. And more, the concept that we are sharing here along with this demo with Jason is it is not on developers' shoulders to actually carry this burden. It is spread across SDLC. And how do you enable the players in the SDLC with a capability that they can tap into and provide the data points? So the moment they start seeing the data points, it becomes very evident that it's pretty seamlessly integrated, and they start taking advantage of the data points to take action. So those data points are pretty important, and we are presenting them in an automated way with incidents and whatnot. And also, the next steps or possibilities that I can show using this is, why don't you take these data points as outliers and feed it into your own APM AI, using an LLM or things like that are provided within the APM platform itself to actually learn what outliers are there in your system. And then you can correlatively create your automated responses. That's the next level that you can move on. Now you're pure play integrating shift left with your APM from a production maintenance and management standpoint to have near zero downtime. I would say, the shift left is pushing towards no ops model where the entire in pure play cloud world. And this becomes a very effective and short way of managing that transition and maintenance. So,
Awesome. Great answer. Thank you so much. We do have some questions that came in. So I'm going to start from the top and we will work our way down with the responses. What tooling is used to run these tests beyond Gremlin?
So it's actually funny that Ananth mentioned Netflix, and that's kind of where this whole practice of chaos engineering came from, because people in the audience might be familiar with Chaos Monkey. That was kind of like the original chaos engineering tool. Basically, the way it worked is Netflix deployed it to their environment. It would go out and find some instance or some node running in their cloud environment and just shut it down. Just take it completely offline. No warning, no notice to developers, nothing like that. It would just take it down and they would see what happens essentially. And what you'd expect would happen is some of their services started failing. Some of them had issues. Some of them couldn't come back up. But over time, as they reinforced and made reliability more of a priority, not just in their technology, but in their company's culture, basically, that the services became more robust. And even if a node did shut down, another one could come up to replace it, or they would have redundancy someplace else. So Chaos Monkey is kind of the original. There are other open source and commercial tools out there. The industry is a bit young right now, but it's definitely growing. And there are a lot of really cool tools with different features coming out. What we're trying to do at Gremlin is make this as not just easy, but also as valuable as possible. So make it easy to run those tests, make it easy to see your reliability in the form of that reliability score, make it easy to find your dependencies and make sure that those are resilient, and also to be able to build your own custom tests so that whatever requirements or regulations you have, you're able to adapt Gremlin to your needs.
I love that. I love that. Thank you for sharing, Andre. We've got one more question, and please feel free to ask questions of our presenters. They're here. They want to answer your questions for sure. Could you explain how Gremlin integrates with different cloud providers? That's a good one.
Yeah, so Gremlin uses an agent-based model to run. The way it works is, we have our agent. It's responsible for orchestrating experiments, but also for just coordinating with the systems you deploy it to. So, for example, if you have I just use AWS because we use AWS as examples all the time. If you have an EC2 instance running on AWS, you would deploy the Gremlin agent to that. Gremlin will, detect that it's deployed to a host, and it will be able to orchestrate those experiments on that host. So if you run a CPU experiment, it will increase the CPU. If you run a black hole experiment or latency, it will actually inject that latency or drop that network connection to that host. But what it also does is provide feedback to our backend services. So since Gremlin's a SaaS service, everything's done through a web interface and our API. So not only are you able to orchestrate those experiments, you're also able to get feedback. So you're able to see, is the host still up? For certain experiments, what metrics is it reporting back? Things like that. So, regardless of the platform you're using, if you're on EC2, if you're on Azure Compute, even if you're using EKS or just a bare bones Kubernetes server or cluster, rather, you'll deploy Gremlin in effectively the same way, and it works effectively the same way.
That's great. That's great. We have another one for our panel today. Great. Keep the questions coming. Broadly speaking, does the increasing resilience... Oh, somebody moved it on me. Hold on.
Oh, sorry.
Does the increasing resilience on automation and Gen AI and SDLC workflows create any greater risk of breakdowns in resilience and exposure to vulnerabilities, which can be especially tricky for institutions like bank? That's from Paul. That was a pretty good question. There's a lot to unpack there.
I can probably help and try to answer. You basically set a set of guardrails in what that automation outcome will be. Here, in the process that we explain on what we adopted, we clearly have a stage where the presentation of the data points is the end of that automated activity. And the data points themselves are collected because we have set up those conditions for failures. In the sense, my functional requirements or my non-functional requirements, my business needs are actually baked into those pass-fail conditions. Those will determine what's my scope and should I look into it. So again, the assessment of these potential issues or the data points is actually done with the developer. In a sense, all the activity leading up to that point to collect the data is automatable. It qualifies under our part, so we automated it. And we didn't put any AI into assessing those data points and qualifying them for resiliency or reliability or not. But the next future possibility that I explained, which is potentially feeding into AI to teach what might be generally the issues or not. Again, your learning model or learning your language model and your learning model that you're setting up for your AI engine can actually determine the boundaries of what can be done and what cannot be considered. So it depends on each individual institution's guardrails to set it up. If it is loosely defined, you're leaving some risk, but not, and you have definitive answers to conditions that are on or off based on your business requirements and risk appetite, then you are controlling it within the known parameters of how it needs to be used. So hopefully that answers your question.
Yeah, great. Thank you so much. We have another question. What factors can be considered to enable resiliency into application at early stage of SDLC?
Anything. I mean, it's like this. There is a reason why the car manufacturers do test their, their finished product to see how safe their passengers are. And it's just not done with one type of crash. It's done with multiple angles, a rollover, a T-bone, a side impact, a multiple rollover, and whatnot. So, and these are all the imagined conditions of what can go wrong in terms of in a crash scenario, and how safe is the passenger and the occupants. Same thing with the application, irrespective of which stage it is in. You can, if you come up with hypothesis of what my failure points can be in my application at any stage, it gives the opportunity to start exploring it as early as possible in your aggressive shift left thought process. So that leaves very little room when you come to the end of your life cycle as you continue to practice it. And after one or two cycles, actually it becomes very seamless and very easy to follow through while you do the learning steps in the first cycle or second cycle. So hope that answers your question. But specifics vary, individual institutions do vary, enterprises do have different set of rules, and how far you are allowed to do that. But end of the day, the idea is to inculcate that practice as early as possible.
Yeah, I agree. I think early implementation typically leads to quicker, I don't want to say quicker success, but more streamlined scalability is, I guess, would be the right word, right? Got another question. What new features or enhancements are in the Gremlins release pipeline? So do you have any exciting things about the product that you'd like to share that you're working on possibly? Yeah.
I'm not sure how much I can give away about what's coming up in the future as much as I would like to. It is a really great question, though. I can tell you about what we have been working on and what we're planning to improve. So recently, if you've been following us, we just released a whole big new onboarding process for AWS. So if you have resources running in AWS, you're able to just essentially give Gremlin an IAM role to see what resources you have available in there. And we'll create your services for you. We'll create health checks for you. Basically, it's one click just to get that one click to reliability testing. And of course, we have that up now, but we're planning to make that improve to just make it as streamlined and as easy as possible. We've also created a new test suite, the well-architected test suite that is designed to test for a lot of the reliability risks you could run into specifically on the cloud, not just on AWS. So test things like, how does your service respond to latency? How does it respond to losing its dependencies? Honestly, a lot of what you saw during the demo that Jason was showing just tailored specifically to cloud environments. And another big feature we released just this month, I believe, is actually more in-depth role-based access controls. So if you're, let's say, the platform team and you're managing Gremlin and providing it as a platform to your developers, you have greater control over who's allowed to run which experiments or in which environments. You're able to set those roles yourself. It's a bit more of an administrative feature than an end user feature, so it's not quite as exciting as maybe like AWS compatibility, but it is still something that a lot of our customers ask for.
That's awesome. Yeah, that's awesome. Improvements are always helpful, for sure, especially with financial services. As someone who did cybersecurity research, I don't know how y'all do it.
You know all about R back then, I'm sure.
Oh, yes, definitely. Well, I do not see any other questions that we have right now. If you have any additional ones, please feel free to reach out to our presenters that we had today. I'm sure they'd be more than happy to answer any questions you have about Gremlin and this topic today. So we're going to go ahead and close out the program. But before we do want to invite you to please take our survey. You can do so by clicking the survey link in your resources section, as your input is invaluable for us. There's also some great handouts that should be uploaded as well that talk more about the Gremlin product. Feel free to connect with our speakers offline if you'd like to learn more. If there's any other topics you'd love to hear from the team here at Gremlin, we'd love to have them back for sure. And the survey is the best place to tell us that. Once again, this program has been recorded. You will receive an email shortly after we conclude in your inbox so that you can view it, watch it again if you'd like to, or share it with others. I'd like to thank all of our speakers today. Really great topic. I think this is a cool product. It's definitely something that's going to be necessary, especially with so much automation coming down the pike anymore. So thank you so much to all three of you for joining us today. We really appreciate it.
Thank you for having us on.
Yeah.
Thank you.
Thanks so much. And for most of all, thanks to all of our viewers that joined us live today. And if you didn't join us live, feel free to catch us on the next one if you'd like. And I just want to thank everybody for joining this Tech Strong learning experience. You all have a good day.
Thanks all.